Okay, let's get into it. We're doing a deep dive today into professional media infrastructure.
Right.
Specifically, how big places like a campus or a hospital can take a standard video signal and, well, turn it into their own internal TV channel.
And the piece of hardware at the center of it all is the Thor Broadcast H-2HDMI-DVBT-IPLL.
Yeah, that name is a mouthful.
Mm-hmm.
But it really is the ultimate bridge between modern video and that old-school coax wiring that's already in the walls.
And that's our mission, really, understanding that bridge. If you've got a feed from, say, a digital sign or a cable box, and you need to broadcast it everywhere, this is how you do it.
So let's talk about the name. DVBT and IPLL seem to be the key parts.
Exactly. DVB-T is the standard that, makes it all work over coax, but IPLL, Internet Protocol, low latency. That's where the story gets really interesting.
Low latency. That's the magic phrase, isn't it? Speed is everything for live video. But first, our sources call this a multi-dynamic tool.
Mm-hmm.
What's that about? Is it really 3 devices in one?
Oh, it absolutely is, and that's a huge benefit. Think of it like this. It's got a 3-in-1 superpower.
Okay.
It can be just an encoder, to compress the video, or just a modulator to create the RF channel, or just an IPTV server for streaming.
But the cool part is that it does all 3 at the same time.
All 3. Concurrently. So instead of buying and wiring 3 different boxes, you've got one. Saves space, power, and a lot of headaches.
So that solves the hardware complexity.
Mm-hmm.
Now let's get back to that critical part you mentioned,
Yeah.
the speed. What does ultra-low latency actually mean in numbers?
Yeah, that IPLL tag is not just marketing. I mean, your typical encoding process can add over a second of delay. We're talking 1,200, maybe 1,600 milliseconds.
And you can really see that delay in a live scenario.
Oh, for sure. It's deadly. This device, it just crushes that down to a range of 70 to 250 milliseconds.
Wow.
It's almost instantaneous. That's why you see it in really sensitive applications.
And you're not sacrificing the picture for that speed.
Right.
Still getting perfect HD quality video.
Up to 1080p at 60 frames per second. Yep. And you get flexibility in how you compress it. MPEG to H.264. You have options.
And it also mentions constant or variable bitrate, CBR or VBR.
Right. And choosing that is important for you as the operator. CBR gives you that guaranteed quality, but it uses more bandwidth. VBR is smarter.
How so?
It just allocates bandwidth depending on how complex the scene is. It's perfect if you're trying to squeeze as many channels as possible onto your existing cable.
That makes a lot of sense. Okay, let's pivot to the physical side.
Yeah.
How does this box actually connect to everything? What are we looking at for inputs and outputs?
So on the back, you've got your 2 standard HDMI inputs, but you also get an ASI input.
ASI.
Asynchronous serial interface. Just think of it as a dedicated digital highway for pro video guys to move streams around. For outputs, you've got the DVB-T and IPTV, like we said, plus an ASI out to pass the signal on.
And the output that goes onto the actual coax cable, the RF modulation, that's where you tune it, right?
Yeah.
To a channel.
Exactly. It handles all the standard options, QAM16, QAM64, QPSK. They're just different ways to, organize the data to ride on that copper wire.
Okay, but how do you control all of that?
Well, that's what's so streamlined. You don't need any special software.
Right, I saw that. It's all controlled through a simple web server on a separate network port.
Yep, you just log into a web page from your browser. It simplifies things so much, especially if you're trying to manage a whole bunch of them.
Which brings us to the scalability.
Mm-hmm.
That's the final piece. You don't buy some massive box for 50 channels. You just stack these like high-tech Lego bricks.
Precisely. The system is designed to grow. You can daisy chain the RF ports from one unit to the next, or use a combiner to merge them all. You can start with 2 channels and scale up to dozens.
So if we boil this all down, what's the core takeaway here? This Thor device is, well, it's that essential professional bridge.
It is.
It gives you the flexibility of 3 devices in one and that critical low latency to turn any HDMI source into a custom high-performance TV channel.
And that leads to a final thought, I think, something for you to chew on. When you have this level of accessible control, all managed from a simple web page from anywhere, how does that change the way a massive organization like a big corporate campus or a hospital distributes critical real-time information? When creating a TV channel becomes that easy, what new possibilities does that open up?